Every April, a group of scientists observes the faint glow of asteroids passing by our planet. One year, they realized there was something weird shimmering in their telescopes. The team expected it to be another asteroid, but they ended up very surprised because what they discovered was an unusual space rock that didn't consist of the minerals that usually make up asteroids. It was made of silicate, the material mostly found on the Moon. They named it Kamo'aliwa, which is a Hawaiian word that means wobbling celestial object. The rock didn't match any near-Earth asteroids scientists had already been familiar with. Instead, that piece had a pattern of reflected light similar to that of the moon rocks astronauts had brought back from NASA missions. This fragment turned out to be a quasi-satellite, which is a kind of asteroids that orbit both our planet and the Sun. It repeatedly circles Earth and has a quite unusual tilt. That's the reason you can only see it in the night sky once a year. The fragment is pretty shy, too. It never gets closer to our planet than 9 million miles. That's almost 40 times as far away as the Moon. Plus, this space body often hides in the shadows. Scientists have figured out the piece won't stay in this orbit for a long time. It probably arrived at its current position about 500 years ago, and its orbit is likely to change in the next 300 years. This fragment may not be alone out there in space. There are at least 3 more similar near-Earth objects. They may have all come from the same place. Researchers aren't sure yet about the nature of the rock, but they can find out more about this unusual space object if they send a spacecraft to collect samples and bring them to Earth. That's something China's space agency is planning to do later this decade. Now, the Moon appeared in the middle of chaos. There are several theories about how that happened. The first one claims the Moon used to be just a wandering body, similar to an asteroid. It formed somewhere in our solar system. Once, it approached too close to Earth and got captured by our planet's gravity. The second theory says that our planet was spinning so quickly that some material broke off and started circling around it. One of the largest pieces was the Moon. The third theory says that the Moon was formed at a time when our planet was going through its own formation process. But today, the most widely accepted theory goes like this. Once, a long, long time ago, but not in a galaxy far, far away, Earth collided with a Mars-sized planet. The debris and clouds of dust from the collision gathered around our planet and started circling it. Eventually, something that we today know as the Moon formed there. Apollo missions brought more than 1/3 of a ton of soil and rock from the lunar surface. These rocks show that the Moon had mostly the same building materials as our planet. This might mean they have a common history. If the Moon had been formed somewhere else and had been eventually captured by the gravitational force of our planet, it would have a different composition. Also, if it had been created at the same time as our planet or had once broken off, there would be the same minerals on both the Moon and Earth. But the minerals on the Moon contain less water. Plus, our planet's natural satellite is rich in materials that form fast at high temperatures. Now, the Moon isn't the only space body in the solar system with a mysterious past. Hippocamp is Neptune's moon, discovered in 2013. It's the smallest moon of this ice giant, a mere 21 miles across. It's very close to Proteus, the biggest of Neptune's inner moons. And no, Hippocamp is not a place for big African mammals to spend the summer. Scientists think Hippocamp probably formed from debris after Proteus collided with a comet. If Hippocamp had entered Proteus's orbit from some other place in our solar system, the bigger moon would have either swallowed it or booted the tiny moon away. But not even Proteus itself is among the first generation of Neptune's moons. It was formed from the remains of the planet's earliest system of moons. Those first moons were destroyed when Neptune captured Triton, currently the largest of its moons. The main evidence proving the collision was likely to happen is the fact that Triton circles around Neptune backward, unlike other moons orbiting the planet. Neptune captured Triton from the Kuiper Belt. That's an area filled with icy objects and rocky debris stretching beyond Uranus. That means Hippocamp is a third-generation moon, kind of like a second cousin twice removed or something. Now, the Sun also had a turbulent past. Our star appeared about 4.6 billion years ago. It's hard to study its early stages of life since that happened 50 million years before our planet was even formed. But recently, a team of researchers has discovered crystals that are over 4.5 billion years old. Hidden deep within meteorites, they've revealed some things about the past of our Sun. Before the planets were formed, our solar system had consisted of a central star and a massive disk of dust and hot gas spiraling around it. As the dust and gases cooled down, they turned into minerals, including the crystals found in the meteorites that landed on our planet. Those ancient materials were irradiated, unlike some younger substances. Researchers think something might have happened to the Sun after those crystals were formed. Perhaps the activity of our star was less intense then. Or maybe, for some reason, these younger materials couldn't travel to the areas where irradiation was possible. Dwarf planets give us a chance to sneak a peek into the ancient years of the solar system. Around 4 billion years ago, Jupiter's, Saturn's, and Neptune's gravitational forces joined. They sent asteroids and comets hurtling across the solar system, making them collide with different planets. All the dwarf planets from the Kuiper Belt, for example Pluto, Eris, Haumea, Makemake, have their own moons that likely formed after some powerful collisions. Icy debris in orbits similar to Haumea's, for example, can prove the theory of an ancient collision. The debris it created simply didn't have enough energy to float away from the dwarf planet's gravitational pull. Ceres, another dwarf planet, has ammonia-rich clays on its surface. Ammonia isn't stable at the temperatures prevailing on Ceres, but there's plenty of this substance in the outer solar system. It means that Ceres was probably formed in those outer parts and got kicked inward. After all, the gas giants were migrating a lot at those early stages of the solar system. Or the dwarf planet could have formed in an asteroid belt, and ammonia somehow, let's say after a powerful impact, appeared on the dwarf planet. Ceres might help scientists understand icy moons better. The ocean floor on Earth has a high concentration of carbonate minerals, and some parts of Ceres have them too. This means this dwarf planet is like some sort of fossilized ocean world. Many exoplanets, a term used for planets outside the solar system, have also gone through pretty intense collisions in their early stages. This double star system is more than 300 light-years away from us, and its stars are at least 1 billion years old. Even though it's not young, this system still shows some signs of swirling clouds of dusty debris that haven't cooled down yet, which isn't something you'd expect from a star system of this age. This debris is still warm. It means there might have been a strong collision of two planets or some other space bodies of similar size in that region and relatively recently. So hey, everybody just simmer down. Dust particles circle around a young star. They stick together and grow bigger with time. That's how planets form. The leftover dust often settles in some distant cold areas. An example in our solar system is the Kuiper Belt. It's located far away beyond Neptune. As solar systems evolve, those particles keep colliding until they're so small they end up being pulled into nearby stars or kicked out of the system. Uranus spins on its side if you compare it with the rest of the planets in our solar system, and the only way we can explain it is a powerful collision in the past. Something much bigger than a regular comet or some other space body of similar size likely hit Uranus and knocked the planet on the side. It was probably a planet twice the size of Earth. It could be a protoplanet. This is a space body made up mostly of ice and rock that orbits a star and is likely to develop into a planet sometime in the future. Anyway, the fallout from the impact smothered the core of Uranus. It prevented the heat inside the planet from escaping. This might explain why Uranus has extremely cold temperatures on its surface. Man, bring a jacket and a blanket.
About 8 billion inhabitants of planet Earth found out the same terrible news in one day. Someone saw it on TV. Others heard it on the phone while scrolling through social media or listening to music. Some witnessed this news in a dream while sleeping. Someone's voice said it in all languages to ensure everyone understood it. I have good news and bad news for you. Let's start with the bad news. You're all characters in YouTube videos in which your planet gets into a situation where the moon breaks in half. For the audience, it will be a hypothetical story, but for you, these events will become a reality. The good news is that I was joking. There is no good news. But don't worry, the apocalypse won't start on your planet. Maybe just a little bit. Have a nice day. At first, the entire population panics. Then, a few days later, everyone calms down. Maybe it was a mass hallucination, and the moon will be alright. But at this moment, scientists have discovered the danger. A colossal meteorite is flying towards us from the distant depths of space. This meteorite is super fast and pretty flat, but has sharp edges. Fortunately, it will miss the Earth by a few thousand miles, but the Moon won't be that lucky. The meteorite flies through our Earth's only natural satellite directly in the middle. So it passes through the Moon, sweeps past our planet, and flies away into distant space. At this moment, all people can't take their eyes off the Moon. The meteorite cuts it perfectly in half, gently, clearly, painlessly. So, what shall we do now? Will the Earth survive this? Our satellite breaks into 2 equal parts, but fortunately, they don't fly away from each other. The Moon's great gravity attracts them back like a magnet. Scientists are sure that the parts will connect in a couple of billion years, and the Moon will become the same as it used to be. But the coolest thing is that people won't feel any changes. Everyone around the world will celebrate this good news. The voice was wrong. But then, another problem appears. A massive meteorite in the form of a shoe is flying from the deepest space to us. It enters our solar system and approaches the Earth at high speed. The space boot crashes into one half of the Moon and then flies away. Now, the Moon is definitely breaking into 2 parts. The first half remains in the same place. The second one is flying towards us. A small meteor shower begins on Earth because of the falling moon fragments, but it's not so bad. Most of these rocks are burning up in the atmosphere. But almost the entire split-off half is falling apart around the orbit of our planet. It forms a stone belt. Now the Earth is like Saturn. Rotating fragments destroy part of our artificial satellites. Communication and the internet work inconsistently. It takes people a couple of years to restore a stable connection. The International Space Station no longer exists. Luckily, all the astronauts managed to return to Earth before half the Moon got to them. So, moon rocks are flying around the planet, and people see half the Moon in the sky. Life doesn't change much for the first few days, but those who live on the coast of the seas and oceans notice the consequences. The Moon used to influence the tides. It was flying around the Earth and made oceans take an oval shape. There were tides on the side where the Moon was closer. There were ebbs on the opposite side. But now, this schedule is wrong. Half of the Moon attracts less water. Yes, the Moon lost half its weight and began approaching the Earth. But its gravitational force has become weaker. Seabirds, many species of fish, sea turtles, and other coastal animals may not survive these changes. Their natural instincts associated with the Moon help them determine the time for getting food, breeding, and flying south. For example, tiny turtles expect a strong tide in the morning. They run to the water, but the water doesn't reach them. Turtles can't hide in the ocean in time and become dinner for seagulls. Crabs can't lay eggs because the tide has started earlier than usual. Wolves go mad in the woods. They howl loudly every night and can't stop. The whole natural world can't understand what's going on. The human body is also feeling some discomfort. Many people have low and high blood pressure, and some experience severe headaches. Half of the Moon changes the entire ecosystem of the planet. Adapting to new conditions will take several tens, maybe hundreds of years. A couple of weeks pass, and people notice the days are now shorter. The Moon always slowed the Earth's rotation and made one day last 24 hours. The Earth is spinning faster now. The night and the morning come earlier than everyone is used to. Earth rotation speed has increased and reduced the number of hours per day to 15. People suffer from insomnia or oversleeping. The body needs time to get used to it. Work schedules are changing all over the world. Previously, people came to the office at 9 and left at 6. Now, they arrive at 7 and leave at 2 p.m. Sleep time got shorter, and people are really sad because of this. Progress slows down because of the short working time. The technologies of the future are now 20 to 30 years late. Hourly pay remains the same, so bosses now pay less for fewer working hours. The whole Moon stabilized the weather and climate on the planet. Look at Mars. It has 2 small moons. They quickly spin around it and rock Mars around on its axis. As a result, strong winds, sandstorms, and thunderstorms often happen on the red planet. Now the half of the Moon that approached us takes the Earth out of stable rotation. This changes the seasonal temperatures in the world. It even gets hotter in hot places. And snowstorms are raging in cold regions. There are short, massive downpours instead of sunny weather. A typical breeze can grow into a hurricane and small waves into a tsunami. The seasons are changing faster now. Winters are colder and summers are hotter. Changing the rotation of the planet affects the Earth's magnetic field. Since the compass and navigation systems are unstable now, we need to recalculate where the north and south are. Birds can't fly south to wait out the winter since they don't know what direction to fly. Their inner compass is broken. Several hundred years have passed. People are entirely accustomed to the new conditions on Earth. New species of animals and fish have appeared. Birds can navigate the sky by the moon again. The planet's economy has been restored. Hourly wages have become higher. People now get enough sleep from 5 to 6 hours a day and work for 4 to 5 hours. The reduction of day and night has also affected the entertainment industry. Movies now last 1 hour. One episode of some TV series lasts 30 minutes. Life goes faster. An average person now lives to be 96 years old. In fact, the passage of time hasn't changed at all. Its calculus did. Several thousand years have passed. People look different now. Now they have big eyes that absorb more light. Half of the moon doesn't shine as bright as the whole thing, so the nights have become darker. It took the human eye a couple of thousand years to develop the ability to see clearly in this new dark. Animals need to navigate better in these conditions, so their eyes have become larger and more sensitive. During all this time, people have cleared the orbit of moon rocks. Several space stations fly around our planet. And again, people hear this strange voice that once told them that they were all characters in one hypothetical YouTube video. This time, the voice says, "Your story ends because the video ends. I'm sorry. Good night."
Have you ever seen the other side of the moon? I caught you. Of course not. But maybe you've seen it in photos. In that case, have you ever wondered why the two sides look so different? Well, let me tell you. We can't see the other side of the moon. People believe this is because the moon doesn't rotate around its axis. But this is not true. The moon does rotate. It just does it at the same rate as its orbital motion. This is a particular case of tidal locking called synchronous rotation. The first time we ever saw a far side was only in 1959, all thanks to the Soviet Luna missions and later the US Apollo program. Now, when Luna 3 and other spacecraft transmitted the first far-side images, they revealed a far more cratered hemisphere that looked more like Mercury or Jupiter's moon Callisto. It looked completely different from what we were used to, and that's when we learned how meh the other side is. No, seriously, just look at it. The near side can boast its thinner and smoother crust. These beautiful dark splotches are called lunar mare, the last remnants of ancient lava flows. And when I say ancient, I mean it. They're more than 3 billion years old. Meanwhile, the far side crust is thicker and crater-pocked. The lava flows had almost no effect on these impact craters. It's also devoid of any large-scale mare. Low-key looks like dried white cheese. To be honest, don't you agree that the nearby side is much more beautiful? Write your thoughts in the comments. So, only 50 years ago, we learned something about the apparent differences. But then the scientists discovered something weird. Both sides are different, even in the geochemical composition. And not only in this, our side was thinner than the far side by several miles. But where did such significant differences come from on an ordinary floating stone ball? For scientists, this was a mystery. They started coming up with a lot of theories. The melted moon theory was the main one for a while. It said that it was the Earth's fault that our moon looks like this. This happened several billion years ago. The moon was born because of a collision. One day, an object about the size of Mars crashed into the Earth. At that moment, a piece broke off from it, which later became the moon. However, this piece was somewhere 15 times closer to Earth than it is now. Some scientists created pictures of the so-called early moon. Unlike our cute little white ball, the early moon was a strange-looking, boiling scarlet ball. That piece didn't leave us after the separation. It became tidally locked very soon after. The Earth after the collision was still an incandescent nightmare, full of fire and lava. It was boiling at a temperature of 4,500 degrees Fahrenheit, and since the Moon has always been turned toward us with one side, this side has melted down a little. This would explain why the Moon's surface, the so-called mantle, is thinner on the near side than on the far side. During the boiling of the Earth, certain elements evaporated from it. They then settled on the Moon. This would explain the difference in geochemical composition between the two sides. But there was a plot hole in this theory. If that's what happened, then where did rare foreign chemical elements come from, such as unusual isotopes of phosphorus, potassium, or tungsten? The nearby site is full of them, and they couldn't have come from the Earth. There were also other theories. Another one said that initially we had two teeny-tiny moons. Later they merged into a big one, hence the difference in their composition. But this theory sounds a bit crazy, and it has a plot hole too. For example, the transition between the two sides is way too soft. If our moon was actually two tiny moons, this transition would be more abrupt. So scientists were kind of at a loss on this one. But recently, they finally figured out what really happened to the Moon, all thanks to NASA's Grail orbiters. They spent over a year whizzing around the Moon, mapping it out, and studying its composition. Using this data, scientists have created around 360 computer simulations. They contain different impacting objects of many sizes, traveling at different speeds. Scientists were comparing the results with our current Moon. They tried to determine which result was the closest to what we have today. And so, they finally solved this 50-year-old mystery. The answer lies in a collision with a dwarf planet. This collision occurred 4.3 billion years ago. This huge object was slightly larger than Ceres. For those who don't know, Ceres is one of the dwarf planets of our solar system. Its diameter is 580 miles. You could say that one France or one Germany would fit into it. So, this giant object crashed into the Moon, somewhere near the South Pole. This collision was so strong that it changed the image of the Moon forever. It left a trail of 3,500 miles behind. It would take you 14 hours by plane to fly that distance. This crater covered the entire near side of the Moon. It caused damage to the Moon's mantle. It also created a so-called South Pole Aitken Base, or SPA Basin. This is an impact crater and has a diameter of 1,600 miles, which is like adding one UK plus one Germany. It's important, though. The formation of this basin was a defining event in the history of the Moon, and it's the second largest impact crater in the solar system. The collision also caused a powerful hot wave to spread across the Moon. This wave scattered over the remnants of those rare warm minerals scientists found on the nearby side. That's how our beautiful side became home to something called Procellarum creep terrain, or PKT for short. This is basically a compositional anomaly, a concentration of potassium, phosphorus, and other rare elements like thorium. You can say that those minerals are a gift to us from deep space. Anyway, there were many, and I mean many, collisions in the Moon's history. All of them only deepened this already large crater. That's why the mantle on the near side was getting thinner and thinner with the years. Also, our gifted minerals gave off a lot of heat, so the mantle has melted a little bit more and more. Oops, this accidentally caused the Moon's volcanoes to wake up. Volcanic activity has increased on the near side. Intense lava flows filled the old empty craters. Ta-da! And this is how the beautiful lunar mare was born. That's about how it all happened. All this information was found thanks to the researchers from Brown, Purdue, Stanford Universities, and NASA's JPL. The research was published by the Journal of Geophysical Research, Planets, so you can read about it in more detail if you're interested. There are still many things we need to learn about the Moon. The highest priority is the return mission from the South Pole, the Aitken Basin. Samples brought from there will be used to determine the age of the Moon, its history, and the nature of the crust and mantle more accurately. Another critical target is the Moscovians. This is the name of a large lava plain on the far side of the Moon. Studying it will help us better understand the difference between the two sides, as well as tell us how the other side was formed. All this knowledge is significant for understanding the history of the Moon, but it's also handy for space exploration in general. Scientists use the Moon as a reference point to determine the age of other planets and entire worlds in space. The Moon helps us determine the chronology of the life of the whole solar system. So, stay tuned for new exciting research and discoveries.